Hello everyone, I am R.Malthy from the Department of Mathematics. Today I am going to handle the topic Introduction to Two-Dimensional Random Variable. Uh, in, in the last chapter we introduced the concept of single random variable. We observed that the various statistical average or moment of the random variables like mean, variance, standard deviation, skewness given an idea about the characteristic of the random variable. But in many practical problems, several random variables interact with each other and frequently we are interested in joint behavior of these random variables. For example, to know the health condition of a person, doctors measure many parameters like height, weight, blood pressure, sugar level, etc. We should now introduce technique help that us to determine the joint statistical properties of several random variables. The concept like distribution function, density function and moment that we define for single random variable can be extended to multiple random variable also. Joint probability distribution. As a simple case, let us consider two-dimensional random variables. We can easily extend the idea to multiple random variables. Consider an example of throwing a die or tossing a coin simultaneously. We get a two-dimensional sample space. The outcome throwing a die is represented as random variable y and the outcome of tossing a coin is represented by random variable x. When both these random variables occur simultaneously or jointly, the probabilities of joint occurrence can be written in a matrix form called joint probability matrix. That is probability of x comma y. Probability of x equal to 0 and y equal to 1 refers to the probability of getting a head and a 1 on the die. Joint cumulative distribution. Definition of the joint cumulative distribution is probability or cumulative distribution function of two random variable uniquely defines the probability of the joint event x less than or equal to x, y less than or equal to y. The properties is f of x comma y lies between 0 to 1 and summation of f of x comma y should be equal to 1. Then marginal probability distribution function is concept of variable are called the marginal distribution function and the joint probability density function is defined as fxy of x comma y of random variables. X comma y is a function such that x lies between x and x plus dy, y lies between y and dy. Double integral fxy of x comma y dx dy equal to 1. Then we should know conditional probability distribution. The conditional probability distribution means x given y or y given x. We should know that is x given y means we have to write probability of x intersection probability of y equal to yj divided by probability of y equal to yj. Here x value will be vary, y will be consistent. Like the same way y given x is equal to probability of y equal to yj intersection of x equal to xi divided by probability of x equal to xi. In this y value will be vary, x will be as it is. We should know one-to-one transformation of random variable. Consider the random of variable x is linearly transformed into another random variable x. And then marginal probability distribution function is insightful and component wise. The marginal probability distribution function focuses on the probability distribution of one random variable while ignoring the others. Conditional probability distribution, as we discussed earlier, we are having two conditions, x given y or y given x. It measures the probability of an event occurring given that another event has already occurred. It's widely applied in statistical modeling and decision making process based on the specific conditions. Covariance and correlation of two-dimensional random variables. Covariance measures the degree to which two random variables together, and correlation means x and y must be correlated in one common point, indicates the strength and direction of the linear relationship between two-dimensional variables. Example of two-dimensional random variables: real-world data, observing pairs of dimension in data sets such as height and weight. Financial market, considering the relationship between stock price and trading volumes. Biological studies, investing the joint behavior of different biological market. Conclusion. Key points are understanding the joint, marginal and conditional probability. Takeaways are essential for interpreting complex data, analyzing covariance and correlation, crucial for making informed decision predictions. Thank you.